Gentlemen, welcome back to the shop. Today we have a very special visitor. That's right, the ghost of Christmas past. It is a Tree Master Journeyman 425 CNC Mill. I was bitten by the nostalgia bug, and everything old is new again. So we'll take a little trip down memory lane. Back when I was maybe 25 or 26, I bought a Tree Journeyman 325 as my first for real CNC machine. It was really my first for real machine tool of any kind. The best part about this machine is what I paid for it. Well, just so nobody thinks I'm a liar, I printed out the actual eBay auction, and you can see right here I paid $102.50 for this machine. But it was advertised as not working for rebuild or parts. And I am told that the machine does not power on, but prior to that issue it had been working fine. So as you might have guessed, the machine was the cheap part of this equation. So I paid $102.50 for the machine. Then it cost $600 for me to get the rigger to pick it up, and another $1,045 to get it shipped to my door. And then I was able to unload it myself. This machine weighs about 6,000 pounds. I think that's like 2.5 metric tons. And I'll give you some of the specs real quick. So it's a Dynapath Delta 20 CNC control. It has a 5-horse continuous, 7.5 horse for 30 minutes spindle motor, 30 inches of X travel, 15 inches of Y travel, 6 inches on the quill, and another 17 inches of up and down on the knee. It takes regular Cat 40 tools. It has a coolant pump, and I believe there's also an air misting system. Most of them have that anyway. So here's the serial number plate. I'm not positive, but I think that this indicates that the machine was built in 1990. But some of the boards inside say 93, so I'm not exactly sure. It may have been repaired at some time. And then, if you don't know, all the Tree machine tools, after they stopped making manual machines, were basically all made by ZPS in the Czech Republic. So the actual iron of this machine is all made in the Czech Republic. So there's the Bijur lube pump right here, and then the air pressure regulator for the drawbar. The drawbar on these is all pneumatic. So here's the main control cabinet. So these are your servo drives up here. It's all DC brush servos. And then this is the control chassis right here. Full set of manuals here came with the machine. So you can see everything inside this cabinet is nice and clean. A couple of transformers there. One transformer is for the control, so that's where you get your 110 volts AC for the control power supply. And then the big one is to get, I believe it's 130 volts maybe, to power the DC bus for the servo drives. So surprisingly very little in this control cabinet. And I think that actually the newer versions of this machine, they just had one cabinet. This machine has two. So you see you got a row of ice cube relays here. That would be for I/O, like turning on the lube pump, possibly the drawbar, different functions like that. You can see the terminal strip here. Somebody's got a jumper on something. We'll have to figure out what that is. And then you check out the DC servo drives. Interesting arrangement. I haven't seen any drives quite like this. On the 325, they're all servo dynamics. These are, let's see, MSI drives. And you see these big Sanrex IGBT modules, and there's like a power resistor here. That's probably for braking, and that's on a steel plate. And then on the opposite side is the PCB for all the control logic for the drives. So on this side we got a big filter capacitor, that's for your DC bus, and then there's a small switch mode power supply, so that would give the drives the plus minus 12 volts that they need to run. And then this is your main e-stop contactor right here. Okay, so the cabinet on the left side of the machine is not so pretty. Now it said in the eBay auction description that the original spindle drive burned up, and I guess I underestimated what that meant. So it looks like it actually physically caught on fire. and you can see on the top of the cabinet how all the paint's been burned off, and then you can see smoke on the top side, and it's actually smoke and it's peeled some of the paint off the door. So they must have had a pretty catastrophic event with the original spindle drive, and that actually can happen more easily than you would think. It's almost happened to me twice. And what happens is the big IGBT modules inside the drive, when they fail closed. And usually what happens is they just start pumping all the DC bus voltage into the braking resistor. So this is not the original braking resistor. It originally would have been mounted up here above the drive. And on newer machines, they put a thermistor sensor on those braking resistors, and if they get too hot, it shuts everything down. But these older machines didn't have that, and what would happen is that the module would short, and then the DC bus would just keep feeding that braking resistor, basically turn it into a giant heater. And you know, they're rated for so many amps, but they have a duty cycle, and if you exceed that, they'll break down and burn up. So yeah, I'm sure all hell broke loose when that happened. Looks like this is not the original breaker, so it probably destroyed that when it happened. And then this is not the original brake resistor, so obviously they just replaced that with something else. This is kind of comically large. And then you can see the wire loom's all damaged here. So must have been quite an event. At any rate, they put a new Yaskawa spindle drive in, and there's nothing wrong with that. This drive probably has better performance characteristics than the old drive anyway. And then there's a transformer and a contactor here and a heater. That's got to be for the coolant pump. And then this machine does not have a power knee, but if it had a power knee, there would be another unit here for that. So down at the bottom of the machine, there's this catch pan here, and then the bottom of the casting is hollow. It kind of serves as a reservoir or coolant tank. But you don't want to run flood coolant on these machines. It just makes a horrible mess. I tried it with my 325, and there's no way to contain it. You know, without the actual enclosure like a machining center, it just goes everywhere. So like I said, no power knee on this machine, which is a little bit odd. My 325 had that, and most 325s I've seen have the power knee. Not sure why they didn't use it on these machines other than cost. And then according to the eBay auction, I guess that this shaft is actually bent a little bit. So I'm sure it's like a Bridgeport. It just runs back to a bevel gear. And then there's a screw vertically. So I may have to take that out and straighten it. Probably got hit by a forklift. That's what usually happens to them. So like I said, it's all DC brush servo motors. These are made by MSI. I think all the 325s are ball door motors, but these look like they're pretty good quality. And I think these all use optical encoders. There's no resolvers on these machines. Alright, so the ways are box ways on the Y and box ways on the knee. And then the bottom of the table is dovetail ways. And as far as I can tell, the ways look perfect on this machine. Yeah, these Y-axis ways just look perfect. There's no scoring, there's no rust. I'm sure they're hardened and ground. And then you can see the wipers right here. Look like they're in good condition too. I would assume that they use turkite or some kind of bearing material. So yeah, it looks good. Got a little way cover here. And then it has this rubber flap that goes over top of it to protect it. And then, I don't know if you can see, but there's actually a grease zerk there for the thrust bearing. That's different than the 325s. I had to replace the thrust bearings on my 325 because they were pretty much worn out. Okay, I took the plastic cover off the top of the machine, and this is the spindle motor and Z-axis servo motor. So the Z-axis servo motor is here. It belt drives the ball screw here. Then that's the spindle motor there. It's on a plate that slides back and forth. This is a little different than the 325. The 325s have some little rollers here that I guess are supposed to keep the belt from flopping around. They have omitted that on this machine, which is a good thing. They didn't seem to do much anyway. And then it's a direct drive, so there's no gearbox. I don't know what the RPMs are on this machine. We'll have to find out. On the 325s, you had an option of either 3,500 or 6,000, and it was basically just determined by the size of the spindle motor pulley and the length of the belt. I don't know what this one is off the top of my head. Now, one thing to check on any kind of a knee mill or any machine with a quill is the condition of the splines. So just take the spindle and try to rotate it and see if there's any slop in these splines. You want that to be nice and tight. If there's a lot of slop in the splines, you can get chatter issues, and your options to fix that are pretty limited. There's just not a lot you can do other than replacing both halves of the spline. So this one looks like it's in pretty good shape. I did see a little bit of a nick in this lube line, so we'll have to replace that. Okay, so this is the inside of the Dynapath control, and on the right side here, that's the power supply. And then each of these cards has a different function. There's a processor board and a video board and an aux board and a servo transducer board. One's input, one's output. There's some digital inputs. Everything looks like it's in good shape. This is a newer version of the control too, so the battery is a little bit different than what I'm used to. Now, the only option that this control doesn't have that I wish it had is the manual pulse handle, but I think that you can add that. We just have to update the parameters, and then you have to have another servo input card, because the control basically treats the hand wheel like an encoder for another axis. So the machine has to be basically 5-axis capable in order to use the manual pulse handle. But I would like to have that. That's a very important feature for a CNC mill. So the Dynapath Delta 20 is an old school control. I think these first came out maybe in the mid 1980s, and the Delta 10 would have come before that. The only difference between the 10 and the 20 is that the 20 can do drip beating through RS-232. The 10 did not have that capability. And the architecture really goes back to the old Bendix controls, but these are still supported by Dynapath. Every time I've ever called them and asked for help, someone has been able to help me, and they've been very nice about it. I know that they repair these boards. I know that they sell parts for these old controls. Everything on here is, the parameters are stored in non-volatile EEPROMs. The backup battery I think is only for the offsets and the programs. And I actually have backups of all the EEPROMs, so even if every EEPROM chip in this control is dead, we can burn new chips. It's not a problem. And thanks to all the hobby home shop guys tearing these out and putting Mach 3 on, there's lots of Dynapath parts available, used parts available on eBay. You can buy every board in this control for 75 or $100 a piece. And as far as I'm concerned, this thing is light years ahead of a Mach 3 control. This is a true closed loop control, meaning that the encoder feedback from the servos all goes through the control. All the PID loops and everything are closed inside the control. The servo drives are just passive amplifiers. So this thing is a true industrial CNC control. One thing that people ask me with some frequency is how to evaluate a used machine, and that's a very difficult thing to articulate, but I'll try to hit some of the high points. So every CNC machine should have some kind of an hour meter, but I've never seen one that couldn't be reset, so you may or may not be able to trust the actual numbers on the hour meter. So it's better just to look at the overall machine. So one thing to look at is the control panel. All these labels are silk screened on, and if the machine has a lot of hours, a lot of times you'll see spots that are worn through the paint or the labels are worn off. You can see this one looks really good. And the other thing is some of the times the buttons get a lot of wear on them. These controls didn't have very good buttons to start with, and these potentiometer switches are pretty delicate too. So that may not be a very good judge in this case. Like you can see, the e-stop button is missing here. Now look at the table on this machine. It's absolutely flawless. Look at the paint back here on the top of the column. You can see that the paint is perfect. It's even perfect right here between the ways. So on these machines, all the chips are going to fly towards the back, and they're going to hit the control cabinet and the top of the column. And if the machine's got a lot of hours on it, this paint's just going to be beat to hell. And you can see here that it's just in perfect condition. Now if the machine is not running, which this one isn't, it's very hard to check the actual condition of the ways or test things like backlash, but you can just see how smooth and basically flawless these ways are. There's nothing wrong with the y-axis ways on this machine, and we can basically look at the bottom of the table and see the same thing for the x-axis. Now check out this cover. This cover basically protects the limit switches, and you can see, anytime you're loading the machine, you're going to be going over top of this cover. And if you're going to drop something, it's going to go right on top of this thing, and there are no dents, there's no dings. Even the paint's almost perfect, just it's a little bit worn here on this corner. So that's a good indication that there's very low hours on this machine. So another good sign is just the cleanliness of the inside of this cabinet. It's basically spotless inside, and the covers on top of the control and the power supply are still there. Seems to have all the screws. The covers on the top of the wire looms are here, they're just not snapped in. If all the wires are pulled out and it looks like a squirrel's been in here trying to make a nest, that's not a good sign. And then if you look at the door, it's got this rubber seal. You can see that this one is intact, and a lot of times they used like a foam and they would crack and become brittle over time, and that allows a lot of dust and dirt to get into the cabinet. These ones are in perfect condition. So there are more signs here that show that the people who own this machine really cared about it. First, the key is here for the electrical panels. So these have these kind of D-shaped latches, and this is the factory key for those. So this little tree plaque would have been screwed to the front of the machine, and you can see it just got brittle and broke. But they saved it, and they saved some of the broken pieces of it, so it should be possible to either repair this or even cast a new one if we really wanted to. And then in this bag here is the broken parts of the e-stop switch, so they saved all of that stuff. So let's quickly discuss some of the pros and cons to these Tree CNC knee mills. Now, Tree was based in Milwaukee, so where I'm at here in the Midwest, especially in Wisconsin and Illinois, there's tons of these machines available. They made a lot of them, they were very popular, and as far as I know, they were all more or less the same. They had the same controls, they had the same servo drives, and there's a lot of machines available, there's a lot of parts available. If you get on eBay, you can find a dozen of these machines, either 325s or 425s for sale. Prices are pretty reasonable. Fixer-upper machines are going between $2,500 and $4,000. Nice machines that are ready to go, anywhere from $4,000 to $6,000. And there are a few kind of outlier machines that have the more advanced Delta 40 or Achromatic 2100 controls. Those sometimes go up to $700 or $7,500. Now, Tree as a company is no longer in business, but ZPS, who actually manufactured these machines, they're still in business and they're still supporting these machines. You can buy parts, you can get service from ZPS in Milwaukee. So the Dynapath control is a good control. It's well matched to these machines. There's a few kind of odd things about it. You can only use one G-code per line. It doesn't have some features like G98, G99 for your retract height on drilling. Little things like that, but you can work around that. It will take standard ISO G-code. You can make, I made several post-processors to work with the Dynapath control. So these machines all use standard Cat 40 tool holders. That's a major plus. The early 325s, like the one that I had, have sort of a bad design on the drawbar. Instead of having a gripper that comes down and grabs the pull set and pulls up with like a stack of Belleville washers like you would see in a machining center, they actually have a set of balls that sort of come in from the side, and then there's wedges that push the balls towards the pull stud. So if you check the pull stud, if you check the drawbar with the dynamometer, you'll see that it has very low force. But actually the tool holder is held in there because the balls basically become like a wedge and it can't get out. But the problem with that is that it's very easy for the tool holders to get stuck in the spindle. So I know like on mine, every once in a while I'd have to tap the tool holder with a hammer, a soft hammer, to get it to release. Supposedly they have updated that on these 425s and the later 325s. So if you're thinking about getting one of these machines, that's something to look out for. Now another thing too is that it's fairly easy to make these machines run on single phase. As long as the spindle drive doesn't have a phase loss detection circuit, meaning that it doesn't know that it lost one of the phases on the input, you can run these machines on single phase. All the DC servo drives, the CNC control, those things are all run on single phase already inside the machine. So you'll lose approximately 30% of your spindle power, but you can run these machines on single phase. Now if you have the power, if you have the knee elevating motor or the coolant pump, those things will not run on single phase. You would need a phase converter to use those two features. But because there's no tool changer, you could pretty easily convert this machine to run on single phase, if that's your thing. So there are some drawbacks to these machines, obviously. Almost all knee mills have the same problems, which is that your quill has very limited travel. It's only 6 inches, 150 millimeters. So if you're going to be running a job with multiple tools, you have to be really careful to make sure that your tool lengths are all the same or very close to the same. Because if you start moving the knee up and down during the operation, either your work offsets or your tool offsets are going to get messed up. So it's not a good idea to move the knee during a CNC program. You kind of have to move that to where you want it and then leave it alone. So another problem with almost all knee mills is that it's very hard to machine something flat because the table is not fully supported. So as the table moves towards the end or extremes of its travel, it naturally wants to deflect down. Now if you look at a machining center, a proper machining center, even a Haas, on the x-axis, the table is going to be fully supported throughout its entire travel. And as far as I know, the only knee mills that are built that way are the Maho mills like the MH800 that I have. Now, it's not an issue for the y-axis. The y-axis is fully supported. But even if you get the ways set up just right, you're always going to have some sag in the x-axis. It's just the way it is. You can't get around that. So the other major drawback to this machine is that it has no guards or enclosure. If you try to run flood coolant on this machine, you're just going to have a huge mess. Especially if you try to run it with like a face mill or some kind of large drill. It's just going to fling coolant and chips everywhere. So in my opinion, it's not even worth trying to use it. Obviously, an enclosed machining center is way ahead of this machine in that regard. So the other problem with these machines is that it has no tool changer. So if you want to run production work, this is not a good machine for you. You will very quickly get tired of changing tools by hand, and the likelihood that you will screw up and load the wrong tool is very high. That's happened to me before, and it's not a good situation. Okay guys, that's going to be it. Thanks for watching. I'm going to let the machine sit right here and acclimate to the shop. I'm going to bask in its nostalgic glow, and when the time is right, we will get into it and figure out what the problem is. I suspect that it's going to be something pretty simple, like a control power supply, or possibly just a wiring issue somewhere. I don't see any reason why we can't get this machine up and running. So I will make a series of videos detailing what I find, and we will go through some of the high points about bringing the machine back to life. We'll go through the lube system. We'll go through checking out the axis condition, setting the backlash compensation, all those fun things. I really don't think we're going to have to do very much to this machine. It looks to me like it's in very good condition, so I'm excited to see what happens.